Hello students, welcome back. Now we are going to talk about servo motors. Servo motors are different from DC motors. They are also rotatory actuators, but they can give you very precise control on the angle, linear position, velocity and acceleration. In DC motor you don't get these controls. So to do that, this motor is having a sensor and position feedback which will keep giving the data that how much rotation has already occurred and how much more we should do to achieve the given goal. In a servo motor, we need a sophisticated controller which is dedicated module designed to use only for these servo motors. Servo motors are available in different shapes and sizes according to the requirement. So they are rated in kilogram per centimeter. So what is the meaning? That means how many kilogram of weight can be lifted by this motor per centimeter. The motors that we use in our regular use, they are normally 3, 6 or 12 kg per centimeter. Industrial servo motors are very highly rated as well. So what is the working principle? Here we have three parts. One is a controller device, an output sensor and a feedback system. All of them will work together to achieve the target. So we use gears first of all because we need to reduce the RPM and increase the torque. Servo motor is not designed to rotate continuously. It is designed to rotate only from one given angle to another given angle. So we don't need high RPM, we need high torque. An electrical signal is used to detect the error. Okay, so if I say my motor has to rotate from 0 to 60 degree, that signal will keep a track of on the angle of rotation. Wherever we detect, we are going to send back the signal that this much error is reported. The feedback will come and we will rectify the error and adjust the angle. This is how all three components work together and we get very precise control on the angle of rotation. So now what is this angle of rotation? A servo motor is designed to rotate from 0 to 180 degree. The degree of rotation is controlled by applying an electrical pulse on the control pin, and servo will check in every 20 millisecond that what is the new value of the signal, and based on the value and the error reported it will keep updating the angle. So here if I have a 20 millisecond pulse and in that I get 1 millisecond high and remaining low, that means I am asking the servo to move only 0 degree. 1.5 is for 90 degree and 2 millisecond is for 180 degree, and now you can see that in between we can adjust the angles by changing the high time of this pulse. So how do we interface this motor with our Arduino board? There are three wires that we need to connect. The first one is red color, which is 5 volt, brown color for ground, and orange for PWM, that will get the signal data that how much rotation should be there. So this is how a small servo motor looks like. The larger servo motors will have more pins and more controls. This is the hobby motor that we use in most of the Arduino projects. So we take the Arduino, 5 volt will go to 5 volt and ground will go to ground, and the PWM pin will go to one of the PWM pins on our Arduino board. Here we have to also take care that we don't need L293D. Servo motor can be driven by the board alone. Now, here we talked about a lot of signals, functions, error detection and all. Do we need something extra to control all of them? Well, yes, we need a library which is servo.h, and in that library you will find inbuilt functions which will help you in connecting the servo motor. So some of the common functions are attach, write number of microseconds, read from servo, and whether the servo is attached or not, whether the servo is detached. So these are some of the functions which are commonly used. More functions are given on the Arduino website and you can check them. So now let us have the onboard testing using Tinkercad. So I have made the same connection. It is connected at one of the pins. Power and ground are given. So first of all we call for the library. I am defining a variable of servo type. The name is servo underscore 7. It can be anything. In the setup function, I am setting up that servo underscore 7 get attached at pin number 7. You can attach at any pin of your choice. In the loop function, we are saying first of all servo.write 90. Here the parameter 90 says that it will go to an angle of 90 degree. Then there is a delay of 1 second, so the servo will stay there for 1 second. Then I have a conditional statement that if the angle of my servo is read by this function which is servo.read and it is greater than 80, then bring the angle back to 90. Servo.write 0. Okay, so if the angle is more than 80, we had already told that it should go to 90. That means this condition will be true. So the servo will come back to 0. And then we are again saying else. That means if the angle is somehow less than 80, again go to 90. That means this servo will keep on rotating from 0 to 90, 0 to 90 with a 1 second delay. Let us verify it now. So we have the connections ready. This is ground pin which is connected to ground. This is power pin which is connected to 5, and this is our signal pin which can go to any of these pins. The code is same what we have discussed. We are attaching the servo at pin number 7, and first of all we are writing 90-degree angle, and if it goes above 80 come back to 0, else go back to 90. So when we start the simulation, we can see this is 0-degree angle. It is going to 90, coming back to 0, staying there for 1 second, and it will keep doing so. There is one very simple electronic component that we are going to discuss next, and those are buttons and switches. These are simple but very critical, and how to use them we'll see in the next video. Thank you.